Hello, today we will differentiate a function with respect to another function. Till now we were differentiating a function with respect to x. Okay, so here we have to differentiate log of x with respect to cot x. In this type of questions, we assume the first function as u and the second function as v. So let u equals to log of x and v equals to cot of x. So actually we have to differentiate log x with respect to cot x. So since we have assumed the another variables, so I have to find that is dv of u. So now since my u equals to log of x, that means u is a function of x. So I will differentiate this equation both sides with respect to x. Then we will have ddx of u equals to ddx of log x, and hence du over dx will be equal to 1 over x. And similarly v is also a function of x, so here also in this equation we will differentiate both sides with respect to x. So I will have dx of v equals to ddx of cot x. So this implies dv over dx equals to minus cosec square x. Now since we have to find du over dv, therefore du over dv can be written as du over dx whole divided by dv over dx. Here we can think that this dx and dx will get cancelled. So this will be equal to the value of du over dx is 1 by x and dv by dx is minus cosec square x. And hence I will have minus 1 by x cosec square x. Or else we can write 1 over cos x is sin x, so we can write sin square x by x also. Question number 2, we have to differentiate sin cube x with respect to cos cube of x. So assuming the first function as u and the second function as v. So I have to find du over dv. So since u is a function of x, so differentiating both sides with respect to x, we will have du over dx equals to ddx of, see, sin cube of x can be written as sin x whole cube, and ddx of x cube is 3x square, that means I will have 3 sin square x, and by the chain rule I have to differentiate sin x also. So ddx of sin x is cos of x. Similarly in the second equation we will differentiate both sides with respect to x. Then I will have dv over dx equals to ddx of cos cube x can be written as cos x whole cube, and ddx of x cube is 3x square, so I will have 3 cos square x, and the derivative of cos x by the chain rule will be minus sin x. So it will be minus 3 cos square x into sin x. Now since we have to find the value of du over dv, so du over dv can be written as du over dx divided by dv over dx. So it will be equal to, let us put the value, then I will have 3 sin square x into cos x over minus 3 cos square x into sin x. 3 and 3 got cancelled, sin square x and this sin x got cancelled, cos x and this cos square x got cancelled, and hence I will have minus sin x over cos x, and sin over cos is tan x. So differentiate tan inverse of square root of 1 minus x square over 1 plus x square with respect to cos inverse of x square. So assuming the first function as u, so let u equals to tan inverse of square root of 1 minus x square by 1 plus x square, and the second function as v equals to cos inverse of x square. So in this second equation, if I operate both sides with respect to cos, then I will have cos of v equals to x square. Now let us put the value of this x square here in the equation of u. Then my u will be equal to tan inverse of square root of 1 minus, see, x square is cos v over 1 plus cos v. So this implies u equals to tan inverse of, we have one formula from half angles, that is 1 minus cos v can be written as 2 sin square v by 2 divided by 1 plus cos v can be written as 2 cos square v by 2. So this is trigonometrical transformation which we have done earlier only. So here 2 and 2 got cancelled, and sin over cos is tan. This implies u equals to tan inverse of square root of, see, sin over cos is tan square of v by 2. This is square and this square root got cancelled. So u equals to tan inverse of tan v by 2, and hence u will be equal to tan inverse of tan x is x, hence it will be v by 2 only. So now since we got the relation between u and v, now let us differentiate both sides with respect to v directly, because now here u is a function of v. So differentiating both sides with respect to v, then I will have d dv of u equals to 1 by 2 is constant, d dv of v. Therefore this implies du over dv equals to 1 by 2, since d dv of v is 1, and we have to find du over dv only, because we had assumed that u as tan inverse of that expression and v as cos inverse of x square. So my answer will be 1 by 2. Question number 4. Let u equals to tan inverse of square root of 1 minus x square over x, and v equals to cos inverse of 2x square root of 1 minus x square. So since we have to differentiate u with respect to v, that means we have to find du over dv. Now before differentiating, let us do trigonometrical transformation by assuming x as cos theta, because if I put x as cos theta, then here in denominator it will be cos theta, and in numerator it will be square root of 1 minus cos square theta, which is sin theta, and sin by cos is tan, and outside we can see tan inverse. So it will be good if I put x as cos theta. So if I put x equals to cos theta, then my u will be equal to tan inverse of square root of 1 minus cos square theta over cos theta. U equals to tan inverse of square root of 1 minus cos square theta is sin theta. So it will be sin theta over cos theta. So u equals to tan inverse of sin by cos is tan, and hence u equals to theta. Now since we had assumed x as cos theta, so from here we can write u as, instead of theta we can write cos inverse of x. Now since u is a function of x, let us differentiate both sides with respect to x. Then we will have ddx of u equals to ddx of cos inverse of x, and it is minus 1 by square root of 1 minus x square. Now let us come back to second equation, where v equals to cos inverse of 2x times square root of 1 minus x square, and we have assumed x as cos theta. So let us put the value of x in this equation of v also. So my v will be equal to cos inverse of 2 cos theta square root of 1 minus cos square theta. So this implies V equals to cos inverse of 2 cos theta into square root of 1 minus cos square theta is sin theta. So now this is in the form of sin 2 theta. So here I can write V equals to cos inverse of sin 2 theta. Now since there's cos inverse outside and sin inside, so we have to change this sin into cos, and we know that cos 90 minus theta is sin. So using that formula here we can write this sin 2 theta as cos 90 minus theta. So cos 90 minus theta is sin theta. So now since we have cos inverse and cos here, that means V will be equal to pi by 2 minus 2 theta. Now let us put back the value of theta from this particular equation, that is theta equals to cos inverse of x. So that means here it will be cos inverse of x. Now since V is a function of x, now let us differentiate both sides with respect to x. Then we will have d dx of V equals to, now see pi by 2 is constant, so d dx of pi by 2 is 0, and here minus 2 will come outside, and we will have d dx of cos inverse of x, and hence this will be equal to minus 2. d dx of cos inverse x is minus 1 by square root of 1 minus x square, and hence it will be 2 over square root of 1 minus x square. Now since I have the value of du over dx and dv over dx, and I have to find du over dv, therefore du over dv can be written as du by dx whole divided by dv over dx. So du over dx is minus 1 by square root of 1 minus x square whole divided by dv by dx is 2 by square root of 1 minus x square. So here 1 minus x square, square root of minus x square got cancelled, and hence du over dv equals to minus 1 by 2. So this is the answer for this question, and this is the last question of this video. So see you in next video. Keep learning, keep practicing.